Hello, fellow chemists. Jolly here again. This time we're going to be talking about resonance. And again, we are doing this applied to basic Lewis structures. So what in the world is a resonance structure? In the very basic sense, it is drawing two structures with, if you will, the same bonds. Now I know that doesn't make quite sense yet, but let me give you an example. So, resonance means, did you put a multiple bond in one location when you could have put it in an identical other location? It's available. If the answer is yes, you need to draw resonance structures. So let me show you an example. This is the carbonate ion. All right, there's a formal charge here and there's a formal charge here, and there's none on that top oxygen. Well, this could have also been drawn. So what's the difference between those two? And then this one could have also been drawn. So what is the difference between these structures? They are called resonance structures, and you indicate resonance structures with a double-sided arrow. This is not equilibrium. This is all possible structures. Why would I draw all possible? It just looks like I'm rotating the picture around. It is the only way that you can tell me this or this or this does not exist. If you can draw a resonance structure or multiple structures that only vary where you put the multiple bond, it doesn't really exist as this looks like a double bond, this looks like a single, and that one looks like a single. But they don't exist. If you were to take a picture of this, what it really looks like is a carbon with three identical bonds with an overall 2- charge shared among them. This is called the hybrid. Okay? So that is what these three actually look like. So, do these three exist? Is there one molecule with one double and two single bonds? The answer is no. But how are you going to be able to tell me that? So unless you get really good at drawing these hybrids, the only way that you can tell me that you know that those don't exist and that it's some kind of combination of them is to draw all three resonance structures. So yes, does it seem silly to just draw the same picture and rotate the double bond? Yes. In future classes, you probably won't have to, but when you're first learning Lewis structures, if you can draw resonance structures, you must either draw all possibilities, or you may draw the hybrid, but this one tends to be easier when you're first learning. And so resonance has something called delocalized electrons. And that will be very important for future reactions, especially in organic chemistry. So if you'll notice these dotted lines, those electrons don't belong to any one oxygen. They are shared or delocalized among the entire system. And that is exceptionally important later on, but we'll leave it at that since we're first learning to draw our Lewis structures. All right, so what are the rules for resonance structures? If you can put a multiple bond in one location when you could have put it in another identical location, you must draw all the resonance structures. Eventually, we'll learn a little more complicated variation, but that's a great place to start. All right, Jolly out.